Good morning, everyone. How's everyone today? So, we're going to get started off here. I'm just going to introduce Darcy Dion. So, for Hydrant 101, so this is the water stream. So, make sure you sign in, get your QR code done for your CEUs. So, Darcy is employed as the utilities foreperson at the Tsawwassen First Nation. She has over 10 years of experience in both water and wastewater. Darcy has worked in private and municipal capacities, but her employment in Tsawwassen within the First Nation community has been her most rewarding work. From ensuring members' concerns are addressed, meeting with developers to confirm longevity and integrity of utilities, and never compromising safety, the gratification is endless. Darcy is currently certified in water treatment, wastewater treatment, distribution, and collection, and is also a CCC tester. Darcy keeps busy with ongoing training, expanding and developing TFN's maintenance programs, and chasing after her 3 little kids. So without further ado, here's Darcy.
Thank you, Chris, and thank you all for being here with me today. So again, I'm Darcy, and I'm currently the utilities foreperson at Tsawwassen First Nation, and I look after the distribution and collection systems. So in 10 years of water and wastewater, I found a lot of inconsistencies in hydrant maintenance and frequency of maintenance. I've seen many municipalities maintaining hydrants as little as every 2 to 5 years in the private sector, and in the private sector, we were doing them sometimes 1 to 2 times per year. Fire code has generally been the standard. However, in recent years, due to staffing and budgetary considerations, there's been a shift. And in other instances, hydrant manufacturers have their own outlines for maintenance as well. In any case, I found all of this overwhelmingly inconsistent. So the purpose of my presentation is that I've gathered fire code regulations, manufacturers' specifications, and what has been working for us in TFN and other municipalities, and share this with you. So a few things I'm going to go over today, a little bit of the history of Tsawwassen First Nation and where we're at today, hydrant history, different uses for fire hydrants, different types of hydrants, fire code, and the inspections and testings involved with that, manufacturer specifications, TFN's unique hydrant circumstances, improper hydrant use and how we deal with it, our goals for the future, and lessons that I've learned. So the Tsawwassen First Nation is a very special community, and I'd like to acknowledge the lands and its members. The traditional language spoken by the Tsawwassen Masteyuch, or Tsawwassen people, is Hunkaminam, and the name Tsawwassen translates directly into English as land facing the sea. According to archaeologists, humans occupied the southwest coast of BC as early as 7000 BC, and by 200 to 400 BC, the Tsawwassen people were well established throughout their traditional territory. The Tsawwassen people had trade and barter systems in place, specialized services were exchanged, ensuring the redistribution of wealth and exemplifying the value that no one gets left behind. They had extensive practices and ceremonies that aided in governance within their longhouse. Experts are still learning how complex these processes were. TFN people were accomplished fishers. Salmon and sturgeon were staples of their traditional diet, and still to this day they fish primarily for salmon and crab. Fish also provides for cultural and social processes that are very important to their identity. So from about 1790, when first settlers were arriving, the Tsawwassen people were decimated due to disease. Their land and resources were stolen and taken advantage of. An unfortunate and recent piece of historical significance was in 1958 when BC Ferries commenced construction of the causeway and tore down their traditional longhouse with no consent. The Tsawwassen people were unable to rebuild their longhouse until 1997. In the early 90s, Delta refused to provide water and wastewater services for Tsawwassen First Nation. At the time, they were struggling to limp along an old wastewater treatment plant and a reverse osmosis water treatment plant, which source water was for very questionable brackish wells. Getting funding and support from the federal government was not easy. During this time, they were constantly threatened with prosecution for non-compliance from the Department of Fisheries and Oceans and Health Canada, despite other governments dumping raw waste and industrial sewage into the Fraser River, Boundary Bay, Burrard Inlet, and Strait of Georgia from dozens of outfall pipes. For well over a century, since 1876, the Tsawwassen people were governed by Canada's Indian Act, which meant decision-making was in the hands of the federal government all the way over in Ottawa. This disallowed the Tsawwassen people from the most basic kind of self-governance, such as expanding the water distribution system in their community or properly treating their wastewater, because local utilities and municipalities would not negotiate with them. Likewise, investors shied away because there was too much uncertainty with the titling of lands and permitting processes. In 1993, they began the process of becoming a treaty self-governing nation. This would take over 16 years with many, many roadblocks. On April 3, 2009, Tsawwassen First Nation's treaty became effective. Tsawwassen First Nation today is thriving, the only First Nation community in the Lower Mainland to be receiving water from Metro Vancouver through two trunk mains supplied via Delta. They own and are responsible for treating their own wastewater and a new wastewater treatment plant that was completed in 2015. There is a large tax base now from joint ventures and various developments for residential, commercial, and industrial uses. They can utilize their land to support their people and continue their mission to becoming self-sustaining. Currently, they are obtaining surrounding lands for expansion of farming. They have built a large, brand-new youth center and since have a 100% graduation rate among their up-and-coming generation. They have completed many housing projects to bring many of their members home to Tsawwassen First Nation lands, and an expansive 10,500 square foot elder center should be completed early next year. So a little bit about our wastewater system. So after the treaty, BC's first modern day treaty, which was for TFN, came about, the wastewater treatment plant was built to facilitate the new mall. The plant currently is running on the first of 3 phases, treating approximately 1,300 cubic meters a day, with a current maximum design capacity to treat over 8,000 cubic meters. We are only 8 square kilometers, but we have 29 lift stations ranging in size and operability, 14 of which have generators for power failure. And all of our lift stations and generators are monitored on our SCADA system and have details like levels, pump cycles, flow rates, and call-out alarms. So since 2011, drinking water, like I said, has been supplied from Metro Vancouver. We are still developing and working towards implementing our cross-connection control program, and we use a company called BSI to track our public, private, and TFN-owned backflow devices. We are currently testing chlorine residuals throughout the system each week and taking 6 BAC-T samples every 2 weeks. We have a comprehensive unidirectional and dead-end flushing programs, and we are also a level 2 distribution system at the moment, but as the pressures increase and the population increases, this is likely to change in the coming years. So let's talk about fire hydrants now. So before piped water main supplies, water for firefighting was kept in buckets and cauldrons around villages ready for use by bucket brigades. From the 16th century, as wooden water main systems were installed, firefighters, who were usually just volunteers, would dig down to the pipes and drill a hole for water to fill a wet well for buckets or horse-drawn pumps to draw from. These holes had to be plugged afterward, hence the term fire plug. So fast forward 100 years, the word hydrant first appears in connection with the city of Philadelphia's progressive municipal water system, which used steam pumps to draw water from the Schuylkill River. This water supplied a system of hydrants which was used for firefighting and a source of water for the poor. Interestingly, if you could afford the whopping $5 annual fee, you could throw your bucket away and have water piped directly to your home. These hydrants consisted of a cast iron standpipe enclosed in a polygonal wooden housing. After 1803, suitable nozzles were installed on the hydrants when hoses began to replace the city's bucket brigade. These hydrants were not designed to deal with ice, so during winter months, watchmen were required to continuously release small amounts of water from each hydrant to prevent them from freezing. It is as early as 1812 that the predecessors of today's dry barrel hydrant first appeared. From 1865, the dry barrel hydrant became the primary basic configuration. They included a stem nut. When operated, a main valve would admit water into the hydrant, and when the main valve would close, the drain ports would simultaneously open to drain the water and avoid freezing, which is much like the hydrants we see today. By 1930s, traffic hydrants had stems that were designed to break off on impact without damaging the main valve. So fire hydrants' main intended purpose is obviously fighting fires. This is why we have them and why we are required to maintain them. Hydrants are also used for filling water trucks, street sweepers, temporary water sources, or supplies. As operators, we use hydrants for flushing in order to maintain water quality, or in some cases, flushing to restore water quality after a main break or rectification of a cross-connection situation. Another important use for hydrants is testing the hydraulic state of our water system with flow and pressure tests. So safety, let's see, oh, here's a video. Yeah, so that guy's not really having a super good day, but yeah. Yeah, so be careful and respect hydrants and their hydraulic capacities for sure. They have a potential to cause serious damage, injury, and death. Air and water pressure are serious considerations when working with hydrants, and never assume a hydrant is depressurized. A good way to verify it is to stand behind the hydrant, loosen a 2.5-inch cap slightly, and it should be loose and wiggle on the nozzle. And if there's pressure behind the cap, it will be pretty stiff and won't move. Like, one of the hydrant reps told me that one, and it stuck with me. It's just a simple thing to do, because you just never know. Always be fit for work, train for the task, and if you're not sure of something, ask. All the hydrant manufacturers offer training, and most of them are willing to come directly to your work site and teach you and your team. Can anyone see the picture with that hydrant there on the bottom? See the problem with it? Yeah, it's pretty gross. So, two things, yeah, there's no air gap, and who knows what's in that tank, and there's no DCVA on there. I'd probably say that you should have a DCVA and an air gap, because who knows what's in there. It almost looks like it could be like sewage or something. Is anyone else in here a cross-connection tester? Nice, awesome. So I recommend all municipalities, First Nations, and utilities have an inspector or tester on staff. The time and cost of training is worth its weight in gold and becoming more readily available across the province. MTS, Kwantlen, BCIT, just to name a few. The public is very uneducated in general about cross-connection because it's, very much an invisible problem. And if we as operators have any opportunity to share or educate, we should definitely do so. So number one, open and close hydrants slowly. We don't need to have races to see who can open or close hydrants faster. Water hammer will cause water main breaks and leaks, and nobody wins when this happens at 3 p.m. on a Friday. So ensure you're on the correct isolation valve. This is as simple as flowing your hydrant through a pressure gauge and closing the isolation valve to make sure the flow stops. Also using the proper tools, parts, hoses, and fittings. Hoses should be proper double jacket fire hoses with appropriate threaded connections, not lay flat discharge hose for sure. Parts should be manufacturers and not aftermarket, and you can verify with the manufacturer of your hydrants which distributors actually carry their parts. And all our pressure gauges should have bleed valves as well. Hydrants are near roads, sidewalks, parks, highways, like we all know. Always be aware of your surroundings, traffic, pedestrians, kids, and animals, and wear your PPE. High-vis, steel toes, good sturdy gloves, and make sure you have a certified TCP when you're required if you're working in dense areas or in areas that are low visibility. So this is kind of where I'm going to go with hydrants today. So we have our hydrants in general, and then we're going to talk a little about dry barrel versus wet barrel hydrants, and then from dry barrel we'll get into compression and slide gate. TFN, we have plugged and draining hydrants. I don't know if any of you have plugged hydrants here. I know you guys do. And then we have two different ways hydrants can be plugged. They can either be plugged in the boot or in the main valve. So dry barrel hydrants are what we have mostly here across Canada, as they're designed for colder climates. They do not hold water in the barrel when not in operation, and the main valve is located below the ground surface in the hydrant boot. Wet barrel hydrants are designed for warmer climates, also called the California hydrant, and they do not hold water in the barrel. Benefit here is that firefighters can hook up multiple hoses without having to shut down and depressurize the hydrant, as there's dedicated valves at each port, which also makes for easy maintenance as the valves are above ground. Slide gates. So I was surprised when I was putting this presentation together. I've worked on a handful in my time, but I was surprised that they're still installed across BC, and places that do have them for their ease of maintenance. They're so simple to take apart. They're definitely not ideal for urban dense regions due to property damage and excessive water loss if they're hit by cars. And as it sounds, the valve is a gate that just slides up and down in the hydrant lead. So again, really simple design. compression. So these are the most installed hydrants today. When maintained and operated correctly, the pressure in the water main actually keeps the main valve seated in the boot of the hydrant. If you look at the lower picture there, when you're opening the hydrant, the main valve actually pushes down into the boot, allowing water to pass through, and alternatively, closing the hydrant pulls the valve up and closed, thus the water pressure in the main keeps it in place. So there's various couplings along the stem. Those nearest to the ground level flange are designed to break if struck or impacted, and these hydrants must be carefully opened or fully opened or closed. If flow or throttling control is required, you should always use an independent gate valve that I have pictured there. So plugged hydrants. Does anybody else have plugged hydrants in here beside the township? Anybody? No? Okay, well, we're going to learn something new today then. So plugged hydrants have been used to protect potable water supply from groundwater, seawater, or floodplain intrusion. I'll discuss the fire code in the next few slides, but a key determining factor is if a hydrant takes longer than 60 minutes to drain, it should have plugs. Plugs can be installed in the boot of a hydrant prior to installation, which is much more permanent, or they can be installed in the main valve, which can be done by simply removing the stem and replacing a few parts. So if you look at the diagram there, that's a Canada valve, so you remove the drain faces and then you have plugs that sit in there, so those won't open when you close the hydrant. The terminal city is that big brass at the top, so you can just buy those and they don't have the drain holes. And then the other one where he's got the socket there, that's a clow, so you actually just purchase those little plugs and can install them right onto your hydrant. And then of course the bottom one, that's where it's plugged in the boot. So when plugged, regardless of how, hydrants require more maintenance and need to be pumped out in the fall to avoid freezing in the wintertime, because they will become like a wet barrel hydrant and hold water in them. So from about 2011 to 2018, plugged hydrants were the specification for TFN development due to concerns surrounding corrosion and high groundwater table. Due to the nature of TFN's development phases, we were able to determine that surrounding hydrants were draining well below the 60-minute requirement, and that as we were kind of moving around our water system and digging up 25-year-old hydrants, we found that they were in really great shape with no corrosion despite older infrastructure having no cathodic protection. A good indication that the water table was also below the boot for us there. Also, these hydrants became a maintenance nightmare and liability in that we were having to replace couplings, rods, main valves, etc. on 4 to 5 new hydrants each season. Contractors would use various hydrants without permission after they'd been pumped out in the fall. They would remain full and freeze during the winter months. Sometimes they would break and leak immediately, and sometimes the damage would go unnoticed until we went to use them, and then we had hydrants with no water to them. In attempting to rid ourselves of the headaches that had come with our plugged hydrants, I reached out to nearby municipalities like Richmond to inquire if they were using them, to which they responded no. So with all of this, I had a case to remove them from the spec. And not to say that these hydrants don't serve a purpose. The Township of Langley has a floodplain region where they use plugged hydrants to protect their potable water supply, and they pump them out in the fall and after they're used. If you do require plugged hydrants, and unless there's an engineered requirement to do so, my only suggestion would be to plug the hydrants in the main valve as opposed to the boot, so they're easy to plug or unplug. So majority of ours in TFN are all plugged in the boot, so it's not really worth it for us to go dig them all up. So this is what we do in TFN to take care of our non-draining hydrants. One, it is a fire code requirement to have any non-draining hydrants clearly marked, and there's various ways you can pump them out. We use drill pumps that are easily accessible but simple to use, but they weren't holding up. So we actually bought that dedicated Purge Pro pump and battery pack, which works awesome. It saves a lot of time. It's simple to use, and yeah, we bought the battery pack because sometimes it's hard to get your truck parked close enough because it does run on a 9-volt. So fire code regulations. So much of the inspection and corrective action points here would be found during a pressure test or B test of a hydrant, which should be done after each use and in the fall as per fire code. Here, it is saying the following should be done at least annually and after use, either because of a fire or for flushing, etc. If you want to make sure you have adequate access around the hydrant, the rule of thumb has always been 1 meter around the circumference. However, fire code does mention here that you actually need a 1.5 meter clearance in front of any connection that's greater than 2.5 inches. So you want to make sure there's no presence of water or ice in the barrel, which is most likely an indicator of an issue in the main valve of the hydrant, which will require further investigation and removal of the stem and an A service. Obviously, your basic visual inspections, the operating nut should not be worn, there should be no cracks or leaks anywhere on the hydrant, and the caps and threads should operate smoothly as well. If any deficiencies are noted, corrective action must be taken. So more details on the testing of hydrants. When you're testing them, they need to be opened fully and for a minimum of 1 minute or longer if the water is not clear. All that stagnant water is required under fire code to be removed from the lead while you're testing it. And then, like I mentioned before, while allowing the hydrant should drain, it should take no longer than 60 minutes. So if it's taking longer than 60 minutes, you have a high ground water table and you should have plugs in your hydrant to avoid a cross-connection situation. So here's some maintenance regulations and mentions here that manufacturer's specifications, which varies. I'll touch on the 3 main compression hydrants in the next slides. This is also referring to your full teardown or A test of a hydrant. Lubrication is a big one. All the threads, caps, plugs, they need to be, and they also need to be in proper operating condition. Again, access is addressed here, and hydrants need to be visible and kept free of ice, snow, and vegetation. And as you can see there, some snowier regions have poles. I think even I've seen them in Harrison Hot Springs. They have poles on there to mark where the hydrants are, so the snow plows don't hit them. So this is our basic hydrant maintenance form we use for a B test. We still have all this information. We don't use paper copies anymore. We do put it in our electronic maintenance program called Lucity. I'm going to start by talking off with a B test, as it's kind of a starting point that sometimes results in doing an A test. And also a B test is the same for all compression hydrants. So B test does fulfill quite a bit of your fire code regulations aside from the lubrication and inspection of the main valve, stem, and couplings. And each hydrant at an absolute minimum should get this level of service. It ensures your hydrant is working properly or further maintenance and inspections required. This is an important record for verification in case of a legal dispute. And so we're all on the same page. We had this discussion yesterday. The C test does not exist. Yes, I see the hydrant is there, is not real, and does not meet any fire code standards. So inspection and testing. These are the basic B test parameters we use in TFN. Make sure it's accessible, straight, hasn't been hit by a car or hiding in the bushes, or like one developer did, used it as a temporary fence post there. They had a big piece of wire wrapped around it. So that's definitely not allowed. I removed the 2.5-inch port and put a pressure gauge on one side and an independent on the other. This allows for a better flush of the hydrant lead. We then open the hydrant, make sure it's smooth, and flush until the water runs clear, again, no less than 1 minute, and then close the independent valve and pressure gauge and get a pressure reading. Does anyone know what the minimum pressure of a fire hydrant should have? Like what the minimum allowable is for a fire hydrant? It's actually 20 PSI. I've only seen that once, so hopefully we have higher pressure than that, but that's your absolute minimum. Otherwise, you're not meeting fire code standards. So after I get the pressure reading, I'll open up the pressure gauge bleed and operate the isolation valve, and this is to ensure the valve is in good shape, it's the correct size, should you require any further hydrant maintenance, and to ensure it's the correct isolation valve for the hydrant. If the hydrant is in good condition, always make sure the isolation valve is left open and a quarter turn back to prevent seizing. The independent valve can also be helpful here. If you can't get the isolation valve to seat, sometimes it's helpful to open the independent valve fully at the hydrant and try to flush out the isolation valve debris as it can get stuck in the seat, and by opening and closing the isolation valve a few times. You may not be able to get the scouring required in the valve seat through a small pressure gauge. Next, you can shut down the hydrant. Make sure you're counting your turns, and they should be the same as when you open the hydrant. And hydrants shouldn't be closed stiffly. When the valve is seated and you get that vacuum at one of the ports, you've closed the hydrant and opened the drain ports. If the hydrant is at all damaged beyond immediate repair, close the isolation valve and mark the hydrant out of service with a 4-inch port tag. Notify your local fire department and let your supervisor know, and then take all reasonable steps to get it repaired as soon as possible. And if needed, call the hydrant reps. I call them quite often if we have hydrants that are hit or beyond my knowledge. So this is our A-test form. It's obviously a little bit more detail. Again, we do these electronically with our maintenance program. This is a complete teardown of the hydrant, and as per fire code, should be done annually, usually in the spring or after a failed B-test. A-test for every hydrant looks a little bit different, but the main idea here is to remove the stem and assess all internal parts, especially the main valve. Okay, A-test. So you can never confirm what's going on inside a hydrant unless you take it apart. So those two top pictures are both different Canada valve hydrants that I'd taken apart. They both operated pretty smoothly when I did do a B-test the year before, but when I opened them up, that's what I found. Like literally that assembly was cracked, and then there was a rock in the other assembly. And these hydrants surprisingly still worked. But again, they'll work until they don't work. So again, this is why it is important that we do take our hydrants apart from time to time. So you want to make sure your drain holes, drain faces, hydrant is in the open position, except the clow. So except the clow should be closed, and this is for when you're removing your stem. Your puck and main valve rubber should have no gouges, rocks, cuts, or be over compressed. Like that Canada valve puck is pretty compressed there. That was also swapped out. You want to check for the stem for bends, broken couplings, missing bolts or pins, and verify that your couplings are all in the correct place and that the breakaway is nearest to the base of the hydrant flange. Your top gaskets, if they're in good shape and not leaking, these can typically be used many times, and cap gaskets. So I found EMCO carries them, the black neoprene gaskets, and they work and hold up much better than the old orange ones. So we have a lot of contractors that are using our hydrants, and I would go and change the gaskets every few weeks, and I have ones that have been in for over a year now, the black neoprene ones, and they're still awesome. So anything that moves or has threads, food grade grease. There's a super lube there, but there's also another one out that the Canada valve rep let me know about. It's called Diana grease, which he swears by, and says that it's actually better than the super lube because we are taking our hydrants apart less often than we ever have, that this grease actually holds up better long term. So Terminal City Hydrants, this is a manufacturer that is adamant about following the fire code in regards to their hydrant maintenance and frequency. They want a complete annual teardown and a pressure test in the fall. They want to replace any hard parts as required, but they do specify that any soft parts, gaskets, O-rings should be replaced annually every time you do your A service. The couplings I've mentioned a few times. We have a lot of our infrastructure that's installed is done by contractors. We are mostly doing maintenance because we're such a small group. But we've found over the years a lot of hydrants that contractors put risers on. They weren't swapping out the couplings appropriately. So you want to make sure that your solid cast iron is your breakaway, and then all the other split ductile iron should be all along the stem. The solid should just be at the base there, and that's meant to break if it's hit by a car. Also, do not over-tighten the travel nut at the top end of the hydrant. So we had this tool made up, which saves a lot of time. It's essentially the travel nut wrench. We cut the top off and put a 1/2-inch drive socket on the top. TC doesn't love this because people tend to like clack, 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 like get the travel nut jammed in there, and you really don't need to. It's just meant as a hold down. It does not need to be put in there with any sort of force, just snug. So if you do make one of these, just be gentle. The stem and main valve should be tightened down firmly, but does not need to be torqued to any set amount. We have approximately 175 Terminal City hydrants. They're super tough, but are the most tedious hydrant to take apart. They require specific tools, and my main complaint is all the different wrenches that you need to take them apart. So we have Canada valve, Mueller, my second favorite hydrant. They also advise following the fire code for maintenance and frequency, a pressure test in the fall, a tear down in the spring. They're much easier and cheaper to maintain. They are the #1 selling hydrant in Canada. They recommend changing the O-rings only as needed if leaking or damaged. No real fancy tours required besides the stem wrench. And as I mentioned, these are more prone to debris getting caught in the main valve assembly. And the only other downside is the drain plugs or drip levers. I find I have to replace those quite often. They're susceptible to leakage if the hydrant is closed too tightly. Another specific item with these hydrants that gets overlooked is when you're threading the main valve and stem back in the hydrant, it's actually specified that the stem needs to be torqued down to 200 foot-pounds. Clow. Oh, I saved the best for last. These hydrants are my personal favorite. Most of you probably know that because I talk about them all the time. All the hydrants, tools, parts, everything manufactured right here in Canada. Maintenance on these hydrants is straightforward. The stem is a little heavier. Manufacturer specs indicate that a full teardown is only required every 3 to 5 years. Unless your annual pressure test and visual inspection turns up deficiencies. They're the toughest hydrant and can handle pressures of up to 250 psi. So they have an internal lubricating nut, pictures that in their mind satisfies the annual lubrication component of the fire code because it's lubricating when you operate the hydrant, which is that, if you see on that, it's that long piece of brass there on the end. Because they specify that these hydrants are torn down every 3 to 5 years, they do recommend replacing all the O-rings each time. So another interesting thing about these hydrants is that the other compression hydrants, you open them and then you put your stem wrench on and you remove the rod. But for Clow, they have a holding nut that you attach to the stem wrench, and they actually want you to close the hydrant up before you try to unthread the main valve, just because they have a drip lever on there that they say can be bent. And I tell them that you guys need to give yourselves more credit because your hydrants are super tough and it can handle it. But that is just a manufacturer's specification that you do have that holding nut and do close the hydrant up before you unthread the stem. So TFN's unique circumstances, that says small group of operators. There's only 3. There's actually only 2 of us right now. The wastewater operator girl got nabbed from me. So our utilities team has always been very small with a lot of infrastructure still going in the ground. We take care of the distribution system, water sampling, complaints, annual reporting, plus the wastewater collection system. We have member-owned businesses and contractors which require use of our hydrants as a water source routinely, and also have non-draining hydrants that many people are not familiar with. I don't like to think of any of these things as challenges. They're just unique circumstances that we've had to navigate through, and I'm going to go into a little bit more detail about this over the next few slides. So one of my favorite parts about working at TFN is that I've had the opportunity to create, develop, and implement most of our utilities maintenance programs, and obviously hydrants being one of them. Based on everything we've gone over as far as manufacturer specs, fire code, my past experience, and our staffing considerations, I had to figure out what was going to work best for us while making sure that our hydrants were going to work when they needed to. Many other jurisdictions have adopted similar maintenance model. The City of Richmond, the Township of Langley, we've kind of found that this works best. Every hydrant is operated at least annually. We've split our hydrants into 2 groups, where 1 year half gets an A service and the other half gets a B service, and then swaps the following year. And obviously, if deficiencies are found, we will take the B test hydrants apart as necessary. This just makes sure that every hydrant gets some level of attention every year. We have about 50 non-draining hydrants, which are now clearly marked, and each October we head out with our little pump and our booster pack, and we make sure that these hydrants are pumped out. And we also paint our hydrants as needed, and it's not on this slide, but we have painted our bonnets blue to match deltas. They've asked that we do so just because they are our responding fire department. So in most utilities, hydrant use is solely done by the operators of the system. However, this has not been the case for us. We really had no way to monitor anyone using our hydrants for a long time, and a lot of improper use caused a lot of maintenance nightmares for us. So we'd find throttled hydrants, and you can see in the top 2 pictures there's a result of people throttling hydrants. Those leathers or drip face would get worn away from being throttled, essentially, having the drain parts partially open. This doesn't only cause issues with the internal workings of the hydrant, but you can also actually cause erosion around where the hydrant boot is sitting. Damaged main valves from over-torquing the hydrants, especially our non-draining hydrants. So when you close a non-draining hydrant, you don't get that immediate vacuum when the drain ports open up. So a lot of contractors would keep reefing on the hydrant wrench because water would still be dribbling out, and they didn't think it was fully closed. So that was a major issue for us. Water hammer, opening and closing the hydrants too quickly, which I would just catch them doing. And then in some cases, there was no backflows, so that was a major cross-connection concern for us. So training and communication. So between TFN growing as quickly as it has, with various developers and contractors working on and building our system, infrastructure, homes, and so on, there was always a need for water sources. As I mentioned, we have many successful TFN member-owned businesses with water trucks and street sweepers that are also involved in construction that require water from our hydrants daily. We had to make sure our hydrants and potable water system were going to be protected while also supporting our members and growth of our community. I developed a hydrant use presentation that I was able to give to our contractors, developers, and essentially anyone who would require use of our hydrants more in the long term. I discussed cross-connection and the importance of backflow preventers and air gaps on trucks. We request test reports for the devices annually as well, their backflow devices. Also appropriate use and techniques to avoid causing damage to the hydrants, as well as safety considerations. We also dedicated hydrants to certain businesses so there's no confusion over access to water. We maintain open channels of communication. If there are issues with the hydrants, they call us and we get repairs done promptly. And if any short-term or temporary contractors or businesses require use of our hydrants, they fill out a hydrant use permit, which I receive, review, and issue. Immediately, I'll make a work order to make sure we get out and test the hydrant for as soon as they're finished with it. If we find any unauthorized use, which typically happens on construction sites, not so much anymore, we shut down the hydrant and remove the backflow. Again, this isn't super common, but I remember a few years ago we had 3 random backflows piled up on my boss's desk. So anyway, we've had some growing pains, but overall things have been doing well with our maintenance program. We seldom have extensive damage or unauthorized use, and I have to say even things have improved further since I gave this presentation last year. So some lessons learned. Working with our contractors and member-owned businesses instead of against them has been beneficial, rewarding, and actually a lot of fun. I've gotten to know members of the community and understand their businesses better. I've been able to spend more time with contractors and have more input regarding our constructed infrastructure. Installation and replacement of hydrants has allowed me the opportunity to work with other departments within TFN. Certain areas of TFN hold a lot of cultural significance, and when digs take place, the archaeological team is involved to witness excavations and take excavated material for sifting at our dedicated archaeological site. And it's not okay to ask for help, it's awesome. The reps for the 3 main hydrants I discussed today are such a valuable resource, and I've never had trouble getting in touch with them. In fact, most of the time, if we have a hydrant get hit by a car or damaged in some way, they're always Brian from Clow, Joel from Mueller, Mike. They're happy to answer our technical questions and even come out to site to see what's going on. Putting this presentation together gave me the opportunity to network with other utilities and municipalities, which is one of my favorite aspects of this industry. This whole room and conference full of operators is a wealth of knowledge we could all benefit in sharing more of. An underutilized but extremely valuable resource is us. This goes beyond hydrants for water and wastewater treatment, and collections as well. The City of Delta shares common ground with us in certain areas and has gone above and beyond to support us. Corix, now Blue Stem, recently came out to our wastewater treatment plant to take some of our sludge and hopes our happy, active nitrifiers could get their plant back on track. The Township of Langley took me out to their floodplain area to discuss maintenance procedures for their non-draining hydrants as well. So goals, as our team grows and develops, I would eventually like to see TFN and an entirely TFN operated hydrant use system where we install and test our backflow preventers with a more comprehensive permit system that eliminates the use for potential user error. Complete and round out our cross-connection control program with policies and bylaw enforcement. And this is going to take a lot of time, resources, and eventually more operators. But overall, I'm really proud of the work we have done and what we have accomplished despite the exponential growth we have seen with a very small team. So I just want to say thank you for your time, and on behalf of myself and Tsawwassen First Nation, Hydrants, thank you so much.
Thank you, Darcy. I guess now it's question period.
Yeah, I'll do my best to answer any questions about TFN or hydrants or the reps or anything at all.
Anybody have any questions?
Hi, Darcy. My name's Richard. I'm from Macedon, Hatigwai, and my listening kept falling behind your pace of speaking, so I missed a couple things. You mentioned an electronic maintenance program.
Yep.
What was that called?
It's called Lucidity.
Lucity?
Lucity.
Oh,
You can take my contact information down too, and if you ever want to email me or call me, I'll be happy to send you any information or documentation that we use.
okay, that'd be good, because I was interested in that battery pack too for pumping
Yeah.
out the water.
For sure,
that,
for
that
sure.
seems like it'd make job sites so much easier.
Yeah, we use it for all of our maintenance. We use it for the maintenance in our wastewater treatment plant, our distribution, and our collection system. I think there's probably other things. There might be streetlights in there. I don't know. That's a question for Mike. But yeah, we use it for a lot of our maintenance planning and asset management and so forth.
Yeah, because like yourself, there's only 3 of us. I got 2 guys running the water and wastewater, and then I'm the manager. So I got to be a working manager. I got to help them out in the field because it's always demanding. You need more than 2 guys in the site, running machine, packing shovels.
For sure. We just have to do the best with what we have. And a majority of this year, I was actually completely on my own, so I don't like to admit it because I'm so proud of my hydrants that I actually did have to contract out some hydrant maintenance this year. So that's always an option too. But again, you have to be really careful. Some guys aren't as reputable as the others, but if that's ever an option for you too, you can reach out. Like I know a lot of private hydrant maintenance companies that will come out and help you guys if you want to.
Perfect. Thank you.
Yeah.
Any other questions?
We do have an online one.
You, perfect.
Yeah. So I'm just going to read this out. 25 psi is a minimum. Is 35 psi because the buster pump of a firefighter truck, they need 30 psi to be functional when the fire is in a multi-level units.
Okay.
Sorry, it's a really long one.
Is there a question or is it just a comment?
No, it's saying, do you is 25 psi the minimum?
Well, I pulled it from fire code. Like I went through all the fire code manuals and everything, and it is 20 psi. I actually witnessed, that is the minimum. Britannia Beach at the very top of their distribution system, right below the PRV from the reservoir, that they have a hydrant that is literally 20 psi. It's as low as it's allowed to be.
Okay, thank you very much.
Did I miss anyone? Oh.
Hi. I'd like to thank Darcy. That was quite thorough and informative, and I think you touched on everything that we do at our city, so thank you.
Awesome. Thank you so much. That means a lot.
Perfect. Well, any more online? Nope.
How did I do for time?
Okay. Perfect.
Is it perfect? Or are
Yes.
you just saying nice?
Okay, so we got a little break, and 11:15 we'll be back for the water with Philip and Chris. So we'll see you in a bit. Sign out.
We don't talk anymore. We don't talk anymore. Ooh, we don't talk anymore like we used to do. We don't love anymore. What was all of it for? Ooh.